Hello, welcome to my channel. I am Ameya, and today we are going to see another beam problem in ANSYS APDL. This time the small change is what we are doing is we are doing a UVL, uniform varying load. Okay, so conditions are same. There is a cantilever beam, one load on the free end, and there is a UVL in between. So let's see how we can implement this. The material property is given as 200 GPa, so that is 2E5, and cross section is a square cross section with a side of 100 mm. Okay, so let's see how to start. I have already opened one document for APDL with the working directory and job name. So we will start with a preference, structural, okay. This is a structural problem. Then preprocessor, element type, add, edit, delete. We are going with the beam element, beam 188. So we have defined the element type. Then we are going with the material property, material model, structural, linear, elastic, isotropic, standard which we do for materials, and 2E5 is the given data. Poisson's ratio, if not given, we will assume it to be 0.3. Okay, so this is about the material property. Then you have a sections, beams, common sections. We have asked for the square section, so we will label it as SQ1 for our reference, and then we will be giving both B and H to be 100, so that will create a square section. Okay, you can see a preview. It will show you the centroid and all the data with respect to the section which we want. You can say okay, just zoom in, zoom out, that preview will be gone. Okay, then we will go to modeling, create key points in active coordinate system. Let us check out the key points. So we need 0 0 here, so 0 1000, we are going with the mm unit, so 1000, then 3000, that will be 4000, and 6000. So 1000, 4000, and 6000. You need 3 key points, 4 key points basically. So let's see, 0 0, I want 1000, I want 4000, and I want 6000. Plot multiplot, that will show you the 4 key points, 1 2 3 and 4. We will create lines, straight lines from this point to this point, this point to this point, this point to this point. Okay, now next step is meshing, and what we will do is we will do the line meshing set for these two lines except the UVL line. Okay, I will show you what happens if you mesh the UVL line with these properties, but we are setting only one property here, so we can go with the attributes, that is fine. You can set these lines to 10 divisions, that is also fine, no issues. You can mesh these two lines, no issues, so you can mesh with it. Yes, yeah, plot multiplot. And for UVL, the only special condition which we need to understand is if you are going for UVL, you will be giving the I and J node different values. Okay, so you cannot have different elements in between the whole length of the UVL. Okay, so whole length of the UVL should have one element. That is the only constraint which we have. So we will set the line type, and in line size we will go and select, instead of 10 we will just do 1. Okay, this will be always because the whole section is having the UVL. Okay, so we will mesh it again, plot multiplot, that will give you the meshing. Now we are going to loads. Let us do the boundary condition first. Okay, apply structural displacement on key points. I will select the last key point and I will put all degrees of freedom because it is fixed from the one end. Okay, and then we will go to the force on key points. This key point I will select. I want a downward force which is having a value of 25 kilonewton. So I am going with 25 kilonewton, so 25,000, and a minus sign for the downward load. Okay, so this is the load, and then we go for the UVL. Just a second, I will close this and then you can go to pressure. So UVL UDL will always come under the pressure. You need two beams, so on beams, and you just need to select the center beam, which is one mesh which we have done, so single element, and you will be going with load key 2 because it is in Y direction. And for I node, so now see the I node is on left hand side, so there is a 0 on I node, and J node is having 30 kilonewton per meter, so 30. So what we will do is we will do I node 0, and this will be 30, okay, and this will be the UVL, okay. Plot multiplot. Then what you can do is you can just go to the solution, solve current ls, okay, that will solve your problem, okay. And then what you can do is you can just go to read results last set for sure, and then you can see the plot result, deform shape, deform plus undeformed. That will show you the deformation. If you want to see the sections, you can go to style, size and shape, and you can put on the section, okay. That will show you the square section, okay. Now what else we can do? We can always the list result, okay, that we have already seen in the last video. You can do the nodal solution, you can do the reaction solution. We are interested in the element table. You can go to define table, add by sequence number, you will go with 6, 19, 2 and 50. Close. We will just verify those numbers from the help menu. Just give me a second, let us verify it. I will show you how to verify those numbers. So later, yeah, in search you can type beam 188. You will get the element properties for beam. You can select that element properties, go to the end of the section where you have a table, and in that you will get this my, that is moment, that is 215, so we are correct in that. And in shear force, you will get shear force in sorry, bending moment in, yeah, just give me a second, yeah, shear force in Y direction, SMIC 6 and 19, so that is also correct. So we have selected 6, 19, 2 and 15. Now you can plot those results by going to yeah, plot results. Then you have vector plot, sorry, counter plot. In counter plot there is element table option, sorry, there is element table line element result option. In that you will go with 6 and 19, that will give you the SFD, okay. Plot control, capture image, save as FD2, close it. Then you can again go to line element, you can have 2 and 15, and then you can capture that. Plot, capture image, you will be saving this BMD2. Okay, so you can do all the type of analysis. This is how you can do the UDL. I will just quickly show you what will happen if you don't do the element going with one. So I will just remove the mesh. So I will delete the load first, delete structural pressure on elements, sorry, yes, pressure on elements. I will select this element, okay. Load key 2 we have given, so I have deleted that, UVL, and then I will go to mesh, mesh tool. I will clear this mesh. I will also clear the sizing. Property will be as it is. So instead of one size, I will go with 5 UDLs, and let's see what happens. Okay. So we have mesh with 5 elements now. So plot multi-plot for your reference. Yeah. So in between we have 5 elements now instead of one element, and then we will go to loads, define loads, apply structural pressure on beams, and you select these 5 beams. Okay, and what will happen? You must have predict it will go something like this, and we don't want this. Okay, this will not reflect into the same UDL which we are doing. So UVL which we are doing. Okay, so be careful. The only rule which we need to understand here is if it is a UVL, you want to go with the one sizing. Whole length should have one element throughout. Okay, so this is what I want to discuss in this video, the UVL part importantly. So if you like this content, do subscribe my channel, follow my channel, and share a word about channel with your friends. Thank you for joining.